This is an overview of 4 geological storage options. We are focusing on the second one, using CO2 in enhanced oil and gas recovery. Mechanism of CO2 in enhanced oil recovery. Supercritical CO2 is miscible with crude oil, resulting in low viscosity, low interfacial tension, and a dramatic reduction of residual oil saturation after water flooding. This slide shows CO2 being pumped into the underground reservoir. Some of the CO2 dissolves in the brine. Some of the CO2 just remains separate. This picture shows a well site with the CO2 being injected into an underground reservoir. Okay, we have a couple of standout examples of enhanced oil recovery using CO2. One is the Wasson Fields Denver Unit CO2 EOR project, which has resulted in more than 120 million incremental barrels of oil during 2008. Another is CO2 EOR is used to produce about 250,000 barrels per day of oil in the U.S. Here is the experiment to show how CO2 can affect enhanced oil recovery. In this experiment, we have oil in the jar and clean sand in the beaker, and we're going to show how oil is recovered. So in the tube we have a mixture of the oil and the sand. Corrine is going to water flood the oil and sand mixture, and the water flows through the oil and sand, and very little oil is recovered during water flooding. Here, Corrine is adding petroleum ether to mimic supercritical CO2 because they have some things in common. They are miscible with crude oil and immiscible with water. They also have lower viscosity and density than crude oil when they mix with oil. Therefore, they can reduce the oil viscosity and enhance oil recovery. This experiment clearly shows that CO2 can enhance oil recovery.